Hey there, year 11. So in exercise 5e, or the technique is called Piecewise Defined Function. It's actually really easy to do this question, but a lot of students get intimidated by the notation. So look at that. That looks scary, doesn't it? But really, what they mean when they say piecewise, it just means that you're sketching multiple graphs on the one axis. Because remember, if you can restrict the domain, say normally if you sketch, I don't know, y equals x, right? This is what the y equals x graph would look like. It would look like that, right? So y equals x will go on infinitely. But what if I told you that I only want to sketch like a portion of it? I only want to sketch from, say, -1 to 1. Then you only end up sketching from here to here, as an example, part of the graph. So you only get that part. But imagine then I want to draw another graph. I might want to draw a quadratic graph, right? A quadratic graph normally goes like this. True? But what if I said, no, I don't want to sketch it, all of that. I only want it from 1 to, say, infinity, right? Then that means I only sketch which portion of the graph? From 1, which is here, and then it goes onwards. So then I only sketch this part of the graph. What you see there is called a piecewise function. So the reason why it feels tricky is because you have to know how to sketch. And then you have to take into account the domain. And that also means that you have to find the endpoints. The endpoints are going to be key. But if you work at it systematically, essentially, you're just sketching in this example here 3 graphs on the one axis. That's it. So it's not really that difficult because it goes back to what you already know, which is sketching, unless you struggle with sketching. So if you can sketch, then yeah, you can do it one at a time. But just to help you along, you can also do this on a CAS calculator as well. So you can type exactly what you see here on a CAS. So here we go. If I were to do this on a calculator as an example, right? We normally go to menu 1 action. So 1, define f of x equals 2. Now, how do you get this sort of set of equations? You can go to the most commonly used function here, right? And you see that there's 2 types over here. Can you see there's the 3 with the comma? The one with the comma tells you can put in domain restriction. This one just tells you sketch 3 equations or solve equations, right? So we've got a domain restriction. So we're going to select this one over here. And that asks you, how many of these piecewise functions do you want? We want 3. Okay, so now we're going to type in -x minus 1. So they want us to sketch a linear graph of -x minus 1, but from x less than 0. So x to be less than 0, control equals, you can see less than 0. 1 done. Next one, 2 times x minus 1. Move to the next domain. So it says 0. It's from 0, x including x, and then x is greater than, and x is less than 1. Okay, then I do the next one, which is half. Ooh. Control divide. Half times x plus, again, control divide 1/2, and the domain is x is greater than 1, so control equals to greater than 1. Press enter. So if I sketch this on a graph setting, you will then see there are 3 different parts to it. So I'm going to go control doc, add on a graph, and you can type f of x because we already defined it. And there you go. You get your 3 different linear equations. You see you got this one coming down, and then in between, and then another one. So together, that's called a piecewise function. But let's analyze this. I'm going to screenshot this so that we can analyze it a bit further. How would you have done this manually? Because you do need to be able to do it without a calculator. So I'm just going to come back here. Let's put this in here. This is my graph. I'm probably going to just delete this just to make a point, or maybe I'll just move it. I'll just move it. How do I move it? Let's just move it over here. Okay. So in this example, we've got this function here, right? But how do we do it manually, right? Let's break this apart. If you do it, tackle it in just a nice, simple fashion, it's actually not that hard to do. It just takes a bit of time, that's all. So here, I like to set up my domain. I like to work on the domain first. So they said x less than 0, right? That's what I got to work with. So I'm just going to rub this out. So x less than 0. So on the x-axis, Where is 0? 0 is over here. And if 0 is there, I want it to be less than 0. So my first graph can only work between less than 0 up until 0, okay, but not including. So that's my first graph. I'm going to color in yellow. Then my second graph, okay, I'm going to do in pink, can only be from 0 to 1. So say on the x-axis, say 1 is here. Then I can only sketch my second graph from 0 to 1. And then my last one, notice I'm going to use cyan here, x greater than 1, anything greater than 1, I want you to sketch the third graph. So greater than 1 from here onwards. So you can see there are 3 portions there. Greater than 1, I will sketch the half x plus half. Now, this is where, once you've got your divide, you work them individually. You take your time. So let's sketch the first one. The first one was negative x minus 1, right? So let's picture it. The first graph is negative x minus 1. And you got to still do your x-intercept, y-intercepts if you normally sketch it, right? So y-intercept clearly is at 0, negative 1, because I can see if you sub x equals 0, y value is negative 1, right? What about the x-intercept? Maybe I should do a different color so it helps you visualize what I'm doing. The x-intercept is when y equals to 0. So here we go, 0 is equal to negative x minus 1. Solve for x, so 1 negative x, and then x equals negative 1. So that tells me that the x-intercept is at negative 1, 0. Cool? So if I were to sketch this graph now, so we've got y-intercept at 0, negative 1, so down here, 0, negative 1. And then x-intercept is negative 1, 0. Negative 1, 0, let's just say here, so negative 1, 0. Then normally to sketch this graph, we would then connect the dots, and this is how we would have drawn it. We would have drawn it like this. We would have drawn the graph like that, correct? That would have been our linear equation for negative x minus 1. But remember, there was a domain. They said that you only draw it within that yellow region. X is less than 0. That means part of my graph, I can only draw up until this point. I'm going to do another color to override it. I can only draw all the way up until this point. That's the only point I can draw up to, correct? So that's the only point I can draw up to. So I'm going to delete what I can't draw anymore. So it only has the yellow part of the component. And remember, because it says not equal to 0, you should technically be doing an open circle here to say that it doesn't equal, the y value can't be negative 1 at that point, right? So that's my first graph. I'm done, okay? Then you go into your second graph. So we go to our second graph, same thing, y2. And our second graph is 2x minus 1. Remember, the domain is from 0 to 1. So I need to, again, same thing to sketch this straight line. I need to find the y-intercept and the x-intercept. So y-intercept clearly is, again, 0, negative 1. Conveniently, it happens to sit exactly the same point as the previous one, so it nicely fills in. So I'm going to fill it in, maybe in red, actually. So I'll fill it in. So I've got that point, and then the x-intercept, we need to find when y equals 0, you got 2x minus 1, so 1 equals 2x, and then x equals to half. So that means the x-intercept is at half 0. So where's half 0? Well, it looks like to me, half is about here. So that must be half 0. So if we were to sketch this, this is what the graph would have looked like. We would have taken these 2 points, and we would have used a ruler, and we would have sketched it. That would have been the graph, correct? But now, remember, the restriction was I can only draw the second graph in the domain from 0 to 1. So where I've highlighted in pink, that's the only region I need. So in that case, I can only work up until this point, roughly, okay? Actually, I'll just do it here. So this point to x equals 0, so it means it's right at this point as well. So that means the only part I can draw is in the pink region is only from here to here. So if I take off my ruler and then I delete the purple, see, that's the only portion that fits within that window from 0 to 1. So notice the second graph only fits in the pink area. True that I highlighted initially. Then in the cyan area, the blue area, I need to draw my third graph. So here we go, my third graph, same thing. What's my third graph? I've got half x plus half, okay. half x plus half. So you can see it doesn't always have to be straight lines, but it could have been a parabola, it could have been anything, but usually they give you a straight line to help you work through this a bit easier. But same thing, y-intercept is clearly at 0 half. Convenient again. Wait, is it convenient? Actually, I don't know. And then x-intercept is when y is equal to 0. I realize I haven't done something. I'll explain what I haven't done later. Solving for x is negative half is equal to half x. And then here, depending on your fraction skills, divide both sides by half. So negative half divided by half equals x. And we know that how many halves fit in halves? 1. But since it's a negative, so it's negative 1. Okay, so it depends on how good your fractions are there at that point. But that tells me my x-intercept is at negative 1, 0. Okay, so... Wait, that doesn't make sense. What did I do? Negative 1, 0. Oh, because the y-intercept is at half, isn't it? Oh, yeah, it does make sense. All right, now, before I sketch this, the thing that I forgot to do, okay, is when I sketch my second graph, remember, I've got the endpoint over here, but I haven't done the endpoint over here. So I actually needed to calculate the endpoint. So make sure to calculate this endpoint as well. So we're going to calculate that endpoint there. Now that's when x equals to 1. We know that x equals 1. We just don't know what the y value is for the second graph. Okay, because we're interested in the second graph that I just drew before. So we're going to go back to this second graph. This is my second graph. And I need to know when x is equal to 1, which is the upper limit of my domain. So remember the domain they gave to us was 0 to 1, right? So I need to now go back and say, okay, well, when x equals 1, my y value is now equal to, y is equal to 2 times 1 minus 1, which works out to be 1. So what that tells me is the coordinate I'm working with is when x is 1, y is 1. Okay, so that's my endpoint. So when I go back up here, I know that this point here is 1, 1. Now that's important to know because when you now calculate the next component, I don't know what just happened here. When you calculate the third graph, sometimes they connect nicely and sometimes they don't. But here we go. So we need to know how to sketch this third graph. Now notice I haven't calculated the endpoints for this third graph. This third graph starts off at x equals 1. Remember the domain? The domain says here x has to be greater than 1. So at this point, what would the y value need to be for the third graph? So I need to figure out when x equals 1, even though it says it can't be 1, I still need to know where that is. So y is equal to half times 1 plus half, and conveniently it equals to 1. So that means the third graph has to begin at 1, 1, which conveniently is exactly this point here. Okay, sometimes it doesn't have to, they don't have to be at the same point. They can start anywhere. So my third graph, I know it starts off at 1, 1. I know the y-intercept, which we calculated before, was half. Okay, so remember the y-intercept we calculated over here, 0 half. So that's my y-intercept there, 0 half. And then I also know that the x-intercept was negative 1, 0. So negative 1, 0 is over here. So if I were to sketch this, this is what the graph would have looked like. It's a terrible one because I didn't draw it to scale, but let's try to make it work. This is what the graph would have looked like. That's what it would look like, correct? Now, remember, I can't, when I sketch this, I can only sketch the portion in blue. So that means when I sketch it, I can't sketch the full graph of the blue. I actually have to only do it from this point, which is where the cyan starts, and then it goes onwards all the way. So this is the section that I would only sketch. That's why when I delete this blue section, that's all I get. And that's what my graph should look like if you were to do it manually. Now you can see that's why the CAS indicates the same thing. Can you see that? My shape is exactly the same. I've got the endpoints all labeled there. What's difficult about this? a lot of things put together. That's why there's only one example, because it takes a lot to show you on to do it. And you can see even in my explanation as I'm doing it, it took me 15 minutes to do it because I'm doing the explanation. If I did it, I probably would have been slightly quicker, but it's still a tedious process. Okay, so part A completed. They wanted me to sketch it. I've done it. And then part B, now that I've got the graph, they asked for the range. Well, you can see that the smallest value that I can have on the y-axis is clearly -1. So that means my range has to be from y is an element of -1 inclusive, because I can have that number. And it seems like I can go on infinitely. So there we go. That's my range. So that's how you would do this question, and that's what this exercise is about. In exercise 5E, you're working on sketching multiple graphs on the one axis. So that's what they're getting you to do here. So you can see you get 2 graphs, and they're pretty simple ones. These are x and -x. X minus 1, 1 minus x. So they're all linear. They're mostly linear, as you can see. They're mostly linear. And then you get to these kind of questions. They can try to put a quadratic and a linear, but they normally try to make it pretty simple. Okay, so even though it looks pretty scary, most of it is pretty straightforward. So maybe when you're starting to work with these questions, that may be a bit trickier, but like I said, work smart, don't work too hard, pick the ones. If you understand the theory and you know how to do it, just pick a 1 or 2 just to practice the skills and then move on. Because the theory is a very simple idea. It's sketching multiple graphs on the one graph. That's it. Okay? So have a go with this exercise. That's essentially all you're doing. You're sketching multiple graphs. You just need to be confident in reading the domain and split the equation up. That's it. Okay? Take your time.